Okay, so let's get started with today's practice test. So, starting out, calcium is in group 2, period 4. What type of ion will a calcium atom form in order to become chemically stable? So, to understand what this is saying, chemically stable means 8 valence electrons. 95% of the time it's going to be 8 valence electrons. So everything wants to get a full valence shell, like these noble gases that don't want to bond with anything. So calcium is way over here, number 20. It's going to want to lose 2 and get a full valence shell just like argon right here. So it's going to want to lose 2. That's going to make it a plus 2 ion. If we lose a negative, that's a positive thing, right? It's giving. This holiday season, let's remember that giving is a positive thing. Bromine is a halogen in group 17. Bromine's right here. So group 17 wants to be in group 18. It's going to get one more electron. It's going to fill up its valence shell with that extra electron, right? If we drew it out, it'd be Br with 7 valence electrons. Somebody's going to give it 1, and that's going to make it a minus 1. So it would be Br minus to become chemically stable, to get those 8 valence electrons that it wants. Okay, write the chemical formula for the following ionic compounds. So magnesium chloride is going to be made out of magnesium. So these two are really like precursors to questions like this. Magnesium is in group 2, so it's going to be a plus 2. So real quick, one more time, 1 valence electron, 2, 3, 4, 5, 6, 7, 8. 8's full. Anything beyond, like these ones, aren't going to give or take because they got what they want. So, 1 valence electron, they're going to give it away, it would be a plus 1. 2, they would give those away, it would be plus 2. 3 would be plus 3. After that, 5 wants to get 3 more, so it's going to get 3, so it's going to be negative 3. 2, negative 2, and negative 1, right? So, magnesium, we look, it's going to be a plus 2. Chloride is Cl. That's going to be in the negative 1. Now, this whole thing has to end up being neutral. So to be neutral, if I've got a plus 2 and a minus 1, that means I need 2 minus 1s. So that's why it's MgCl2. I can also do the thing where I do the crisscross, where I bring this 2 down, and I take just the 1 here, not the negative, bring it down here. The chemists are lazy and they don't write 1s if they can get out of it. So, that's A. Iron 2 sulfide is Fe2 plus. S is 2 minus. So I know that this is 2 here because of the Roman numeral. It goes right there. Boom. Sulfur is minus 2 because it's in group 16. Now when these two are equal to each other, you don't have to cross anything. It's already equal. It's just going to be FeS. We could also have iron 3 sulfide where we would have to cross. So iron 3 sulfide would be Fe2S3. Ammonium iodide. A bunch of people asked me where's ammonium on here. Found americium. Did you spell it wrong? No, ammonium's over here on the polyatomic ion list. This one's upside down, but don't forget about yours tomorrow on the test. It'll be right side up if you turn your thing right. So, NH4 plus has a charge of +1. It's a +1 ion. Iodide Iodine is going to be a halogen right here. It's in the -1 column. So I -1, and that's just going to be NH4I. Barium phosphide. Barium is in column 2, so that'll be a +2. Phosphide is in group 15, so it'll be a -3. We crisscross, and we get Ba3, P2. Aluminum. Aluminum's really the only +3 that we get that's not going to be a transition metal. Boron doesn't really bond ionically, it's more of a covalent bond. So aluminum sulfide is going to be Al3 plus S2. We do our crisscross, and that's going to be aluminum 2. So Al2 S3. Sulfides and sulfates are different. A sulfate is made out of a bunch of things bonded together. Well, actually, it's not a bunch of things. It is... it's 5 things. So it's SO4. And the whole thing is a -2 charge, right? I don't know. Let me check. Yeah, it's a -2 charge. So I put it in brackets because I got to treat it as all one big thing. It's very stable. Sulfates aren't going to break down easily. So we do the crisscross, and we would make this Al2 SO4 3. It's going to be a pretty huge molecule, what with 12 oxygen, 3 sulfur, and 2 aluminum. Anyways, differences between ionic and covalent bonds. Ionic bonds are metal and non-metal. Covalent bonds happen between 2 non-metals. Oh, spelling. What the heck? 2 non-metals. Those are metals that you like to nom on. Ionic bonds. So the metal gives electrons. So the electrons are actually being given from the metal cation to the non-metal anion. Whereas with the covalent bond, the electrons are being shared. Covalent seriously means shared valence. So those electrons are orbiting around both atoms. 50% of the time you'd find it in one, 50% of the time you'd find it in the other. Okay, drawing these Lewis dot structures to create stable molecules. Okay, so first off, nitrogen and hydrogen. Nitrogen, hydrogen. We've got 2 nonmetals. I know hydrogen's on this side, but it still counts as a nonmetal because it's a gas. It's not a metal. So that's going to be covalent. So when we draw it out, nitrogen has 5 valence electrons. Hydrogen has 1, but it only wants 2. So it's going to share. So it's going to share instead of given, and it's going to share instead of taken. So we would get NH3, something like that. If I pause real quick, run over here. So if this ball represents nitrogen, it has 3 places where it's going to share. I would just bond my hydrogens on right there, and I would get something like this. So one more on there, and I would have an ammonium ion. This itself is ammonia. Fluorine. If I bond fluorine with fluorine, that would be 2 nonmetals, right? So that's covalent. When I do that, I'm going to have, well, fluorine is in group 17. There's our most reactive nonmetal. You would not want to be in a room full of this fluorine gas, because it's going to react, with like your skin and eyes and burn them off. It wouldn't be fun. So, just checking, we want to make sure that we have 8 valence electrons around everything, right? So 1, 2, 3, 4, 5, 6, and then these count as 2, so 7, 8. Okay? Same on the other side, we've got 8 around each. With sodium and chlorine, they're going to form sodium chloride, so Na. This electron is going to go over and hang out with Cl. It's too good to be with sodium. So what that's going to do is that's going to make Na positive, and then Cl is going to be negative because it has one more electron than it has protons. So we've got a positive, we've got a negative. They're going to attract each other due to that. Okay, naming these models or molecules. C is carbon. 4 is tetra. So this is carbon tetrachloride. S is sulfur. 2 oxygen is going to be dioxide. P is phosphorus. Br5 is going to be pentabromide. Okay, and that's it. Okie dokes. And the lights stayed on so far.